Welcome back to Mastering C++ 20 features. In this and next lecture, I will discuss about coroutine with co-return statement. Co-return keyword, just like co-yield and co-await keyword, is also a new addition in C++ 20 and can only be used in context of coroutines. They are analogous to the classical return keyword appearing in functions in C and C++. That is, co-return marks the end of coroutine execution. A coroutine can have two types of co-return statement. First type is co-return in a coroutine that co-returns nothing. This is similar to void returning functions. Second type is coroutine that co-returns some value, and this is similar to a non-void returning function. In this lecture, I will explain how to create coroutine with an empty co-return statement. First, let's see an example of coroutine with simple co-return statement. Let's call this coroutine foo that returns a return object like in the previous lecture. A simplest coroutine that does nothing and co-returns will have just a single co-return statement. And this kind of coroutine is analogous to the functions that does nothing and returns void. Like we saw in the previous lecture with co-yield keyword, here also we need to modify promise object to make co-return work correctly. The structure of promise type must provide a method return void in its public interface, and as shown in the slide, this method returns void. The method return void is executed automatically by the runtime system when an empty co-return statement is encountered in the coroutine. In the function definition of return void, one doesn't need to do much except for providing some cleanup tasks like freeing up resources held by the promise type or the coroutine handle before the coroutine finishes execution. Alright, let's see this in a live demonstration. Here on top of the file, I have the same return object as in the previous lecture, but with slight modification that the promise type struct has a method return void in line number 8, and this method has a void in its return signature. From line number 22 to line number 26, we have the same foo coroutine as shown in the slides. This coroutine simply prints some statements on the standard output and co-returns. In the main function, the coroutine foo is called and the return object is captured in a variable, following which the coroutine handle from the return object is also captured in another variable which is called handle. And from line number 36 to line number 39, the coroutine is conditionally executed and resumed if it has not finished execution. Right now this code will not compile since the method return void is not defined. So let's go ahead and do this. In the most simple cases like ours, we don't need to add any cleanup code, so we can leave the body of return void empty. But for the sake of clarity, let's just add a stdcout statement. Noting that the method initial suspend returns suspend always awaiter, this coroutine will suspend on the initial call and will resume execution only when it is resumed from the caller of the coroutine, which in this case is the main. Now if I compile the code and run the executable, we see from the console output that the coroutine suspends on initial call and returns the control back to the caller, that is the main function. And upon resuming the coroutine in the main function, the first two lines in the body of the coroutine is printed on the console. And finally, the empty co-return statement inside foo is executed, which in turn calls the return void method within the promise type struct, which prints the statement inside its body, which we can see here. And finally, the coroutine finishes execution and the program exits. That was all for this lecture. Thank you for watching this lecture. In the next lecture, I will show you how to work with coroutines that have a non-empty co-return statement. So stay tuned and enjoy learning coroutines. See you in the next lecture.